Hello, everyone. My name is Matteo Menolotto, and I'm a senior postdoc researcher at Tyndall National Institute. My research activity involves the use of human-centric data to develop decisional models that can be used by the Industry 5.0 ecosystem to improve safety, productivity, robot autonomy, and workers' well-being. Robots are becoming an essential component of the manufacturing sector with the recent deployment of the so-called collaborative robots, able to give the level of flexibility in terms of implementation that is allowing even middle and small-scale enterprises to take advantage of automation. Unfortunately, collaborative robots are such only by name. The collaboration as an exchange of bidirectional information that allows two subjects to complete a task in synergy at the moment is lacking, mainly due to the lack of information coming from the operator to the robot. So we set our research interest in line with the confirmed goals towards the implementation of sensing framework and the decisional models that will enable us to tackle such a big limitation in today's automation. So the first step towards the creation of such bidirectional communication is the implementation of a sensing technology that is able to collect information from the operator and at the same time provide the worker with the ability to feel and control the robot. We have developed a haptic glove that could be used for this purpose. The hand, after all, is the best way to start with because it is the tool we use to manipulate objects and explore the environment. And so the next step was the assessment of the level of accuracy in motion tracking that will allow us to effectively and precisely teleoperate a robot. In the literature, we could not identify a standard methodology to do so. So for glove-based devices, especially for the dynamic behavior. So we developed a new comprehensive accuracy assessment protocol that includes a stress test of the pose estimation algorithms under different acceleration and velocity profile via the use of a pendulum. The subject usage and assessment over different grasps and hand configurations were also assessed and compared against a high-precision camera-based motion capture system. The results show the glove accuracy is comparable with the best performance of the other data gloves available in the market, and therefore can be used for robotic teleoperation. The benefit of having a wearable sensing device able to detect pose and acceleration of the operator's hand of course gives us the opportunity not just to use it for teleoperation, but also to collect human-centric information that can be used to assess and monitor many other important aspects such as safety, ergonomics, and to optimize specific industrial tasks, which are usually performed in collaboration with a robot, as the one we are seeing now in the video. So the next step will involve the collection of open source databases of motion tracking data regarding the tasks that we classically see in Industry 5.0 between workers and collaborative robots. We will use those to create AI-based classifiers to distinguish each task in real time. This information will be used then to inform the robots and other subsystems on what is the operator task that is currently going on, which will be used to set the correct interaction behavior that optimizes safety, productivity, and many other features. Together with this, we have also started the assessment of human factors in collaborative robotics, which are, again, trust, ergonomics, and many others. And those are all crucial aspects to take into consideration when humans and robots work together. And so we hope with this to, in the near future, improve and optimize the whole collaborative robotics in the Industry 5.0. Thank you very much.